Please welcome the world-renowned structural designer Sri Umesh Joshi.
In order to become Viksit Bharat, we need to imbibe professional ethics on our entire community. That's what I mentioned, that when we are talking of innovation, we will have to incorporate that as an innovation because that is something missing from our brain somehow. And unless you try to absorb in entirety that we would like to have nothing but code compliant structure. What is code eventually? We talk of various laws like CPC, CRPC. So similarly for engineers like us, the Bureau of Indian Standards codes, even though they are recommendatory in nature in the first place, when National Building Code makes it mandatory through government regulant organizations, it becomes a law for us. And somehow in our country, we tend to overlook it. And if you want to create a good law-compliant buildings, this is something we will have to take it up. And I look forward to the new generation, that whatever mistakes my generation did of chalawing, wo band kijiye. We need to be as stringent as most of the developed countries are. So that is something I would like to really emphasize, and we should take it to our heart to be completely compliant with the law. And mind you, the codes are changing continuously. See, whatever code we had, when I learned in 1984, the code that we had has no relation to what I am following now. So you simply can't be saying that this is something what I had done for last 40 years and I will continue to do the same thing. That is not acceptable, that is not tenable, because the knowledge is evolving. Like, in medical science, we used to depend only on ECG then, when we didn't have 2D echo, we didn't have CT angiography. But today, when CT angiography is available, now you say that ECG is the starting point. You can't take it for granted that whatever results we are getting out of it are final. So similarly, our knowledge is getting developed in a much faster way, and we will have to go and be compliant with the new requirements. Unfortunately, in our country, we don't have a code of ethics. Most of other countries have a code of ethics. So the professional ethics, which I will define, that remain transparent and truthful to the client. Because I always say that when I design a building for the developer, I am not responsible merely to that developer. I am responsible to a common man who is purchasing an apartment over there. Because he is investing his whole lifetime savings. Not only that, possibly he is also banking upon additional loans, a liability that he has created for himself, which he will be repaying for rest of his life.
Mechanisms of structural integrity, the precise ratio of cement, the quality of the rebar are permanently sealed away inside the walls.
And that is something we will have to be very careful about. Any low-rise building, you can possibly build it anywhere because it will have to only resist the gravity loads. But when we are talking of a high-rise structure, if we have an option, we should always examine the location of the building, because especially now we are sitting in Ahmedabad right now. Ahmedabad has a few fault lines nearby. They are around 40 to 50 kilometers away from Ahmedabad. If you are trying to construct a really high-rise building near fault line, then that is going to make that building more vulnerable, and hence to make it safe, it is going to be more expensive. So unless it is mandatory, you should avoid going to a very high-rise structure on the fault line. Any critical structure on the fault line will always pose issues. And that's why the seismic hazard level will have to be specifically understood. The seismic hazard, when I mean, it was broadly classified into zones by Indian Standard Code, like Zone 2, Zone 3, Zone 4, Zone 5. Zone 1, which I had mentioned in the panel discussion, was there in Latur, but we got a shock of our life, and then subsequently Indian Standard Codes completely abolished the Zone 1, which was the lowest zone, because Latur was classified under Zone 1 and it suffered an earthquake of a magnitude of around 6.3, which had a devastating effect because the hypocenter of that earthquake, hypocenter is the depth of the focal point, was merely 10 kilometers below the ground level. That's why it created a bigger damage, and that's why those zone levels were immediately changed. Now we have a much more sub-geological data available, so we have created a deterministic hazard level in our building profile, and that's why in the new code you will find that we have a higher hazard levels, especially now for Ahmedabad, where we are now right now. Till 15th of November, Ahmedabad was in zone 3. Now it has been taken to zone 4. So higher hazard level. Chandigarh was in zone 4. It has been taken to a newly formed highest hazard level, which is zone 6. So Calcutta again similarly has gone from zone 3 to zone 4. So these changes will keep on happening, and we will have to keep ourselves compliant with that. Similarly, even wind directionality plays an important role in selection of the building. Now, if you go to Mumbai and when you are constructing high-rise buildings, as you know, we get southwest monsoon, and Mumbai's basic prominent wind directionality is from southwest. So if you make a building which is slender for wind coming from southwest, you are going to make building less efficient. So if you can have certain elevational elements which will confuse the wind and reduce the impact of wind, then that is much better. So gone are the days when an architect can alone design a building. Ideally, for a high-rise building, the architects and structural engineers will have to work in tandem right from the sketching stage. That means architect cannot be sitting in a silo and said, no, this is my kind of idea, this is aesthetical concept, this is what the client wants, and this is the way I'm going to design the building. You are invariably going to get into problem because structural engineer is going to say, no, this is something I can't do, this is something I can't do, and then you will have to go back to reworking. That is something to avoid. Now everywhere in the world, all over, all high-rise buildings are done in tandem with the design of structural engineers and his concepts taken into account right at the time of sketching. So that is something we need to remember. Also, soil investigation is very important because what has been emphasized now, that the type of soil that you have plays a large role in how the building behaves under seismic conditions. In places like Ahmedabad, Delhi, where you have a softer soil, the earthquake many times tends to get magnified. But suppose you are going to a place like Maharashtra, Mumbai, where most of the high-rise buildings are there. Mumbai is comparatively safer because eventually at a varying depth between, let us say, 8 meters to 15 meters, you have a basaltic hard rock at that level. And that rock tends to dampen your vibrations to a very large extent. And that's why geotechnical investigation is an absolute must. See, many times when we talk of geotechnical, we bore a hole into the ground of a 4-inch diameter, and that is taken to a depth of around 40 to 50 meters from the ground level, because we need to understand what are the non-uniformities of the formation in the soil, because that is eventually going to affect the building performance, especially of a taller nature. So that is something very critical that we have to keep in mind. Now this is again coming to why someone asked a question that why Japan came out of nuclear holocaust so early and why we are struggling. See, we have so far virtually refused to create basic documentation like design basis report. As I said, our generation has made mistakes. They said that is not needed, this is understood, that is understood. No. We will have to clearly create a proper articulated design basis report so that once the design basis report is created, everyone including the authorities will know that you are trying to comply with all the regulations. And that design basis report will have to be made mandatory as a part of submission along with the initial proposal. And that DBR is absolutely mandatory. Now, in the new code that is becoming mandatory, the code which has been now published in 2025. Also, gone are the days that you can do it with hand calculations. Software platforms are absolutely important, and you have to be completely conversant with those software. Now, as I had been talking of code compliant, I would suggest that all your design basis report at least should make mention of these codes. This IS 456 is the basic foundation for the concrete design. Then 800 is the general construction, again basic code for the structural steel design. Then 875, the 875 various parts relate to the loading standards. That means right from the gravity load, wind load, snow load, other superimposed loads, all those standards are given. Next. Then 1893 is the basic earthquake code. That is something you will need to comply with. And this is the new version which has come about only 15 days before. We are still struggling to understand what are the changes. But that is on us now, that we will have to implement it in next 3 to 6 months. Then 13920 is ductile detailing. I will not take your time in terms of understanding the technicality, but to make people understand in a common man's language that we cannot make earthquake-proof buildings. Let's all understand one thing. The best effort on our part is to make an earthquake-resistant building. In a way, that means if an event has to occur and affect you, there should be sufficient time for the occupants to escape from the building without getting hurt. The damage cannot be ruled out. Damage to some degree is expected. But our emphasis has to be on life safety so that the occupants are able to escape within a reasonable period of time. And for that, the building has to have a capability in technical language of what we call it a deformability. That means the building can sway, the building can bend, the building can deflect without experiencing a complete collapse. That is something called as a ductility. And that ductility in case of earthquake engineering is most important. And now for the first time, as I said, how do you classify a tall building? The tall building eventually has now Bureau of Indian Standard has made a definition that present class of tall buildings is minimum height of 50 meters, that means around 16 floors. And today code covers buildings up to 250 meters. That is around 70 to 75 floors or 80 floors roughly. So that is now classified as tall building, and the tall building there are clauses which will define as the rules for actually kind of scaling or preparing the plans for the tall building. So this is general what we had been talking about, that the building has to be robust. It will have to have adequate redundancy. This is something all of us engineers have to remember. Like in our say nuclear family, one bread earner unfortunately dies, then the entire family is exposed to the vagaries of life. Suppose you have a joint family and you have 4 brothers, 5 brothers, and something unfortunate thing happens to one brother, the rest of the 4 brothers take care of the entire family. So there is some amount of redundancy in the family to take care of the total work. So your building should not be so designed or proportioned that is dependent upon only one column. You need to sit with the architect and negotiate with them that I want another load path, what we call as in the event of an extreme earthquake event. Suppose one of the column gives away, then there has to be an alternate load path. As an engineer, that is something we can always remember. Nowadays, the code has also got a tendency not only give the mathematical formulation, but they prescribe that I want height of the building and width of the building restricted by this. I want the structural type framing system restricted by this. Now this is something what I had been telling Bureau of Indian Standards, that This is something you need to circulate in Council of Architects, because eventually architects design the building. What the code says for tall buildings, certain structural systems you cannot avoid. That means if you want to have a building, for example, in let us say zone 3, which is 200 meters tall, then you will need to have shear walls definitely. You cannot be going on column and beam alone. Column and beam alone is just not allowed. See, moment frame is not allowed in zone 5 and 4 at all, and in zone 3 only up to height of 60 meters. The moment your building height goes above 60 meters, you need certain amount of shear walls in the structure to make the building safe. So this is more of an architectural provision. Honestly, this is something you will need to sit with the architect and tell him that, look, our building is going to be 150 meter tall. We are going to be in zone 4. Then I will have to have complete shear wall distributed across the plan of the building. Their architect cannot say now that, no, I don't like shear walls, they create too much of obstruction. No, that is structurally not allowed. And that is something we'll have to emphasize, and we'll have to abide by these things. Now we are talking about also slenderness ratio. This is most important, and these figures are widely followed world over, that the building's height to least lateral dimension, that means the width. When we talk of least lateral dimension, that is the width. If your building is 150 meters, and if I am talking of an aspect ratio of 8, that means I need to have a building which has a width of not less than 21 meters. Let us put it this way. The aspect ratio of 8 cannot be exceeded. You cannot say that I am going to have a building which is only 10 meters wide at the base and which is going 160 meters tall. No, that building will be pencil thin, that will be unsafe, that will be slender. So that is not permitted by the code. And these clauses have been specifically provided under the Tall Buildings Code. This is the elephant in the room, that we used to float the columns. Possibly the architects' friends who are in the audience, they will understand. Because on many 5-star hotels and other commercial premises, not all columns can come from the foundation level. Because you have banquet halls, you have lobbies, you have in malls various entrance foyers. But now code says that in seismically active areas, the columns which are resisting your earthquake loads can be floated. No, they said that the columns which you will assign them for the earthquake load will have to come from the foundation to the top. They cannot be floated. And people keep on arguing with me. That means even at this stage of my career, I keep on arguing with the architect. And the code very clearly says that this feature is undesirable and hence should be prohibited if it is part of or supporting the primary lateral load resisting system. So explicit provision has come. And the next big thing is that most of the buildings with open story are vulnerable. So stilts, you have to be very careful in terms of sizing the columns in stilts. I know that right now no one is into structural design, but these are the basic do's and don'ts that any common person will also understand. If someone is giving you a very slender column in the parking which is an open story, it's not a very good structure. Please bear in mind. That is going to create a problem. Even now, column width, people want 6 inches wide column, 9 inches wide column. They don't want the projections to come in. It is not defined that width of the column will have to be at least 20 times the diameter of the reinforcement in beam and not less than 300. That means the minimum width of the column for a common man will have to be 12 inches. If someone is giving you column which is less than 12 inches in width, that means he is not code compliant. And why people do not remain compliant, I'll tell you, for the simple reason. As I had said, the gravity load is for life. 100% of the time, every minute, your gravity load you have to resist. But earthquake happens once in 40 years, once in 50 years, once in 20 years. So even if I don't remain compliant, I am never tested. Because if the earthquake doesn't come in the lifetime of me as a designer, then I'll say that whatever I have signed, the buildings have been safe. Because your buildings are not that frequently tested for the earthquake. But When it gets tested, people get found out. That is something we observed in this city only. So we need to be very careful on that. This is one more thing which I just wanted to introduce if people are not aware, that for tall buildings, we have to go for the wind tunnel testing also. What we do, that the buildings which are taller than 150 meters or the first dynamic period is more than 5 seconds, we send it for testing. Now even in India that facility has become available at Thiruvananthapuram. Previously we had to go either to Canada or Australia to get it tested. Now at Thiruvananthapuram the facility is available. Next slide. This is something which I wanted to show. This is a photograph of the wind tunnel test we conducted. This is fitted in the wind turbine on a turntable, and a building model is created to the scale of 1:400. A complete model is created that is placed with what we call as a proximity study. That means now on the basis of GPS, you can map the surrounding buildings for the obstruction to the wind. So those are also modeled and created as a prototype around our tower. And this turntable is rotated 30 degrees or 15 degrees. So in 360 degrees rotation, you have around 24 cases. And the wind keeps on blowing at a pre-decided velocity. And then your building is tested in multi-directional response. And the building is instrumented completely, and this gives you complete force mechanism and the moments which are coming on the building. For buildings taller than 150 meters, this is mandatory by the code. For the time being, without being too technical, I hope that I have tried to make it clear to a commoner in terms of not using very complicated language, the intricacies involved in the high-rise buildings. I won't say exactly challenges as Rajni said, but these are the intricacies that we need to keep in mind. That's all about it. Thank you very much.